Why, hello there, my little mathematicians. Today, we're going to do the warm-up of PL-34. I want you to practice mainly just setting these problems up, okay? If you feel like you want to solve them, you can always hit pause, try to work it out, and then I'll put the answer up, and so you can quickly unpause it before I put the answer up. And then you can check to see if you got it right. But mainly what I want you to do is I want you to practice setting each of these problems up. So it says for number one, the Better Butter Company packed 400 pounds of peanut butter into jars holding 2.5 pounds each. How many jars were used? Okay, so first of all, let's just go ahead and write down some of the important information that they told us. Always label what you're talking about. This is PL-34, and we're doing problem number one. They told me that we have 400 pounds of peanut butter, and we were able to put 2.5 pounds into each jar. Okay, so when it says each jar, that means like one jar. So 2.5 pounds goes into one jar, and we have 400 pounds. So how many jars did we use? When you have problems like this, where you have one number with one single unit, pounds, and another set of numbers with two units, the units are pounds and jars for this one, I always start with the one that gave me one singular unit. So I'm going to start with the unit of 400 pounds. And then I'm going to use what I call the conversion unit, the one that gave me two units, the one that gave me pounds and jars. I'm going to put the thing that has like units diagonally across from each other. So I'm going to put those pounds diagonally across from each other so that eventually they'll cancel out and I'll be left with the unit of jars. Okay, now I'm going to use this conversion unit right here. They said 2.5 pounds, so 2.5 pounds went into one jar, so one jar. And then pounds cross out because they're diagonally across from each other, and I'm left with the unit of jars. How I know what to do with my numbers is if they're across from each other, I multiply them. If one's on top and one's on the bottom, I divide them. One's on top and one's on the bottom, so I would plug this into my calculator. I'd get 400 divided by 2.5, and you get 160. Okay, now technically this is in the decimal unit, which means we actually wouldn't be allowed to use a calculator. So if you were to have done this by hand, when you're dividing by 2.5, you can't divide with decimals, so you'd move the decimal over in the divisor, which means you also need to move it over in the dividend. When there's no decimal present, it's at the end of a number. Because think of it, if I were to write like $400, I would write it like that, right? But it's implied that it's 0.00. I just don't write the 0.00. So when there's no decimal present, it's behind the number. So as of right now, the decimal's here. And since I moved it once in the divisor, I need to move it once in the dividend. So now I have 25 into 4,000. And when I do my long division, I get 160 jars. Okay, but mainly I just wanted you to kind of practice the setup so you would know if you multiply or if you divide. And if you're like, what in the world is happening with those numbers? Like, why did those cross off? Why is 400 over 2.5 mean that you divide? Think of it in terms of if you were multiplying a fraction. Let's just make up this, for instance, of 7/4 times 8/7, okay? Isn't it true that these sevens cross cancel and become one, right? Like they cancel out and you just get one. And then I know that you can cross cancel the 4 and the 8, but let's just not for right now because I want to show you when numbers are across from each other, you multiply them. 1 times 8 is 8. 4 times 1 is 4. And a number on top of another means 8 divided by 4. So 8 divided by 4 is 2. So these pounds canceling out is kind of like how the sevens canceled out. And just how we did, we multiplied across, we got 8. We multiplied across, we got 4. You multiply across, 400 times 1 is 400, and 1 times 2.5 is 2.5. So you have 400 over 2.5. That's like 400 divided by 2.5, just like it's 8 divided by 4 to give you that too. Okay. All right. Now that we kind of established that, we can go a little bit quicker, hopefully, through the rest of these. Okay. Number 2 says Mrs. Vroom used 15.6 gallons of gasoline to drive 348 miles. How many miles did she travel on each gallon? Well, for this one, you have 348 miles that you went on 15.6 gallons. And you're like, okay, well, how do I know if it's miles over gallons or gallons over miles? What helps you make that decision is this one says it wants to know how far you went on each gallon. So you want gallons to eventually become 1. So you want the unit rate of per gallon, right? They didn't give me any other numbers. This is it. And so I just want to put gallons on the bottom, and then to find the unit rate, you just divide by whatever is in the denominator to both the top and bottom. Because essentially 15.6 over 15.6 is just 1, right? So essentially you're reducing it by 1, which doesn't really change the number. Okay. Whatever you do to the bottom, do the top as well. And the reason I chose to divide by 15.6 is because anything divided by itself is 1. 15.6 divided by 15.6 is 1. Now I have 1 gallon. And then do the same thing on top, 348 divided by 15.6. Okay. If you were to work that out, whatever comes first goes inside the house. And it's this divided by 15.6. You can't divide with a decimal, so move it over here and add a 0. And now you have 156 into 3480. If you want to work it out, go ahead and press pause and then unpause when you think you have it. If you've unpaused, when you worked out the problem, you got 22.30, which is then just 22.3 miles per gallon. All right. Let's go ahead and take a look at our next one. Our next problem, number 3, says Snapshot paid $4.50 to get a roll of 24 pictures developed. How much did he pay for each picture? Because yes, back in the day, this is how it worked. We didn't just have all the photos on our phones. Okay. So right here, let's write down our information. Okay, I want to find the money it cost per picture, is what they said. So it cost me, or I should say Snapshot, paid $4.50 for 24 pictures. That's it. That's all the information they gave you. And then you want to find the unit rate. You want to know how much it is per picture. That's how I knew to put pictures on the bottom. So I'm going to divide by that bottom amount. Okay, so you would have 24 into 4.50. You don't need to move the decimal because there's no decimal in your divisor. So you would just start dividing. Okay, and then that would give you how much money it is per picture. Because in the bottom, 24 divided by 24 is 1. So you have 1 picture. Okay, go ahead and try to work that out if you want to. And when you come back with us, okay, you should have gotten 0.187. And yes, it could have kept going, but we're talking about money, which only goes to the hundredths place. So I only needed to go one more place further than that to see what it rounded to. Well, this 7 tells this 8 to go up, because if the number behind the one you're focusing on is 4 or below, this stays the same. If the number behind the one you're focusing on is 5 or above, it tells us 1 to go up by 1. So since it fell into the 5 or above category, I'm going to bump this 8 up 1 to 9. And so now it's 19 cents per picture that I figured out for number 3. Okay, let's go ahead and take a look at number 4. Let me fold this so we could see better. Okay, number 4 says Chemo pays $41.50 per month for cable service. And I'm jealous because I've been on the phone for an hour and I don't pay that for cable. Not even close, even after arguing with them for an hour. So hold on to this price, Chemo. Last month, he watched TV for a total of 90 hours. Chemo, you need to start doing something else. How much did Chemo pay for each hour of viewing? Okay, so what did they tell me? They told me he paid $41.50 and he watched 90 hours. And I want to know, how much did he pay per hour? So that means I wanted hours on the bottom because I want to know, I want to eventually get per 1 hour. Okay, how do I do that? I find the unit rate. So I'm going to divide both the top and bottom by 90. 90 divided by 90 is 1. So you have 1 hour. And then for the top part, you would take $41.50 and divide it by 90. Okay, go ahead and try to figure that out. Press pause, then unpause when you think you got it. So for this one, when you divide 90 into 41.50, 90 can't go into 41, right? So those are zeros. And then you bring up that decimal, but 90 can go into 415. It goes in 4 times. Okay, keep going. I'm talking about money, so I only need to go out 3 places because money is 2 places and you always go 1 further than what you need. That 1 tells this 6 to stay a 6. So it was 46 cents per hour of viewing. All right. Also, I know that I've been telling you guys to pause when you figure it out, but also please feel free to pause it when you think you want to try to set it up yourself as well. Okay. Number 5 says when you buy 6 compact discs, that's what they call CDs. CDs are those round discs that play music when people put it in a CD player. So sad that I have to explain this. For $39. You get 1 additional disc free. What is your cost per disc? Okay, so let's read that again. When you buy 6 CDs for $39, you get 1 additional disc for free. What is your cost per disc? Okay, so question 5, they want to know the cost per disc. So I want money over discs. They said I'm paying $39 for how many discs? If you said 6, you were close, but it was 6 plus that additional 1, so 7. Okay. I want to find the money per disc, so let's find the unit rate by dividing the denominator by itself and then do the same thing on top. 7 divided by 7 is 1. So if I find what 39 divided by 7 is, I'll get the cost per disc. Go ahead and figure that out. Again, whatever comes first goes inside the house. Whatever comes second goes outside the house. And you see that that goes in 35 times. And here you're like, wait, why is she doing this one with us? Because the other ones already had decimals. This one doesn't. So when you get to this point and you're like, there's nothing else to bring down, add a decimal and a 0. And now bring that 0 down. Now you can keep going. 7 goes into 40 how many times? And I can do that. I can add a decimal and a 0 because isn't 39 the same thing as 39.0? Yes, it is. I didn't change the value of it at all. Okay, try to figure that out. Remember, you always need to go one further than how many places you need. Okay, and since we're talking about money, you should have gone out. You need to go 2 places and then go 1 place further than that. So this 1 tells this 7 to stay a 7. So it's $5.57 per CD for that one. Okay. And if you're like, oh my gosh, you moved the paper away so fast, remember, you can always pause it on those to check your long division. Okay, number 6. Number 6 says the fastest train in the US can travel 2.6 miles per minute. At that speed, how far does it go in half an hour? This one's a little bit tricky, huh? Let's write down what it gave us. Okay. Well, it said, problem 6, it can go 2.6 miles per minute. So in 1 minute. How far can it go in half an hour? I want it in terms of minutes. So half an hour is 30 minutes. Okay, so this is one of those ones like problem 1 where they give us multiple pieces of information. Which one do you think we should start with? The one that has one singular unit, the 30 minutes. Okay, so let's start with that. I'm going to use this guy, my conversion unit, and you always put what across from each other? The like terms. So what unit should go here? Minutes. And then miles on top. So we said it could go 2.6 miles in 1 minute. Now minutes cancel out. I'm left with miles, which is good because it says how far can it go. So I want my unit to end in miles. And this time they're across from each other. So when they're across from each other, that means multiply or divide? Multiply. So I'm going to do 30 times 2.6. Go ahead and work that out. And you should get 78. Okay, if you needed to see the math on that, there you go. 2.6 times 30, that's how you get 78. Let's go ahead and move on to number 7. Number 7 says Mrs. Butternut used 12 ounces of cookie dough to make 20 cookies. What was the average weight of each cookie? I don't know, but I'm sure I'm hungry now. Number 7 says 12 ounces of cookie dough to make 20 cookies. What was the average rate we want to know per cookie? Okay, or each cookie is the same as per cookie. Which means average is another way of trying to ask you about the unit rate. So I want cookies on the bottom because it said per cookie, which, all right, we already have that. So 12 ounces for 20 cookies. To find the unit rate, you divide whatever's in the denominator to both the top and bottom, because anything divided by itself, 20 divided by 20 is 1. Now we know per 1 cookie, but do the same thing on top. 12 divided by 20. Go ahead and work that out. Okay, and now you unpause and you're with us. The first thing I want to make sure is that whatever comes first goes inside the house. A lot of people probably did 20 inside because they're like, 20 is bigger. Whatever comes first goes inside the house. 20 can't go into 12. So you add a decimal and a 0. And now 20 can go into 120 6 times, because 6 times 0 is 0, 6 times 2 is 12, and you get a remainder of 0. So I get 0.6. 0.6 what? 0.6 ounces. Be really careful. I hate when they use the unit of ounces because doesn't that look like a 60? It sure does. So a lot of times, like when I write it, I usually try to go slow and I write it further out from it, and I write it a lot tinier than this so I don't get confused later on and accidentally think my problem's a 60 instead of 0.6. Just a little tidbit because I've made that mistake way too many times, and I don't want you guys to make that same mistake. Okay, let's move on to number 8. Number 8 says a math workbook is 0.5 inches thick. Let me go ahead and flip this so we can write up here. Okay, so we have problem 8, 0.5 inches thick. How many of these books will fit on a shelf that is 36 inches long? What do you think? Multiply, divide. Well, you're trying to figure out how many of something will fit into the other one. So this is a division problem. What divided by what? Is it 0.5 divided by 36 or 36 divided by 0.5? It's the space that you have divided by how much you want to put on each one. Remember that you can't divide by decimals, so I need to move it over in my divisor. However many times you move it in the divisor, move it in the dividend as well. And when I move it here to take that place, I'm going to put a 0 placement holder. So now you have 5 into 360. Go ahead and work that out. And you should get 72. You can fit 72 books on that shelf. Let's go ahead and take a look at number 9. 2 more. We're almost done. Number 9 says a machine uses, write this down, 0.8 gallons of fuel for each hour that it runs. The fuel tank contains 10 gallons. How long will the machine run? Why don't you go ahead and try to solve this one? So press pause and then unpause when you think you got it. Now that you're back with us, hopefully you started with the singular unit, 10 gallons. And you want to put the units that are alike across from each other so that they'll cancel. And my conversion unit was 0.8 gallons for 1 hour. And that's great because gallons canceled, I'm left with hours. And the question asked me, how long will it take? And hours is a unit of time measurement. Do you think you multiply these numbers or divide? You divide because it's top divided by the bottom. So 10 divided by 0.8. So whatever goes on top goes inside the house. Top dog goes in the house. Bottom goes outside. I can't divide with the decimal, so I move it. Move it the same amount inside. I need a 0 placement holder. So now you're doing 8 into 100. And what did you get? You should have gotten 12.5. So it took 12.5 hours. Okay, again, if you need help seeing the long division, press pause when I rewind it, and then when I put the answers up, press pause so you can check your work with it. Okay, number 10, our final one. Lucinda ran 3.7 miles in 30 minutes. What was her average time for each mile? So they want to know each mile, which means we want miles on the bottom. This happens very rarely that it's not distance over time. Okay, so that's why you always pay attention when it says whatever it's asking for and it says per or each, that's what they want on the bottom. So I want to put miles on the bottom, and then that puts minutes on top. So it's 30 minutes is how long it takes for me to go 3.7 miles. So how long does it take me to do each mile? So how long does it take me to do 1 mile? And I figure out 1 mile by dividing the denominator by itself, because anything divided by itself is 1. Do the same thing on top. So now you have 30 divided by 3.7. You can't divide by a decimal, so move it over, which means you need to move it over in your dividend. And now you have 37 into 300. Go ahead and work that out. Pause it. Press unpause when you got it. And now hopefully you unpaused it. You're back with us. And when you did this, you got 8.1 miles. Or sorry, 8.1 minutes. 8.1 minutes to do 1 mile. And there you go. That was pretty tough, huh? So some of these, let me just show really fast. Okay, if they give you like 2 different pieces of information and 3 different sets of units, so 10 gallons and then 0.8 gallons per 1 hour, that's when you have to do like one of these conversion things, and you put like units across from each other, they cancel out. And then if one's on top of the other, it's this divided by that. So 10 divided by 0.8. If when you do a conversion, okay, you know, again, we still put the like units across from each other. They canceled out. If they end up being across from each other, those 2 numbers get multiplied to get your answer. If they don't give you like 3 pieces of information, instead they just give you like this, and then they say, find how much it is like per mile or for each cookie or for each mile, then we're trying to find the unit rate. Or they could also say find the average. That's another way of asking to find the unit rate. Make sure to pay attention. Whatever it says, like find the average amount of this, that goes on the bottom. Or how much is it each cookie or each mile? That's what goes on the bottom. All right. And then you always divide the denominator by itself to get the denominator to become 1, and then do the same thing on top. You only move the decimal in the divisor, and then however many times you moved it, do the same thing to the dividend. All right. This was pretty tough. If you did well on these, congratulations. If not, don't worry. It takes practice. We got this. We're going to get there.